when I start swinging, how far off the ground am I? Really? You're still on the swing. If swings sat on the ground, they wouldn't swing very much, would they? So we first of all have to start a little bit off the ground. That's the first thing. Most of you probably have it starting at 0. That's cool if you did, because you could make an argument that that is the 0 height of the swing, right? But let's, if we're going to, lawyer ball ourselves, which you all insist on doing every chance you get, let's be honest, the 0 would be right on the ground. All right, now, what's the first thing that happens when you make a swing start going? You got to stand up, don't you? And back up a little, right? How far up does the swing go? Not much, right? You're sitting on the swing, you're up to here, right? Okay. What happens to time? Time keeps going. So I go a little bit up, yes? Then I lift off my feet, and what happens? I go forward, but what happens to my height? Because this is not about direction. My height goes down a little first. Now, can it ever go below this line? No. And then what? Now, if I'm a good swinger, I should go up a little bit higher each time, shouldn't I? Right? So I down, and I'm going to go up a little bit higher. Now, what should happen to the steepness of these lines? It should increase. Why? Not only am I going higher, I am going higher in less time, yes? So I go up a little, down a little, up a little more, down a little more, up a little more, down a little more. Will I ever go all the way around? No matter what your big brother or older cousin said, man, when I was in grade 3, I knew a kid in grade 6 who swung all the way around the bar. It's impossible. You can't do it. Huh? It's impossible. You cannot do it. What? How is it impossible to swing all the way around a swing? You cannot gain enough force to get all the way around. Unless you have solid bars and you're on that kind of swing. Do you understand what I'm saying? If it's a swing set on a swing with chains, as soon as you get up high enough, you fall straight down. You cannot do it. It's impossible. But you can do it if it's solid bars. So, that's what it would look like. Now, be honest. Did some of you draw, because I said to split your page, did some of you draw this? What's wrong with that?
Time's going backwards.
Time is going backwards. Right there, right there, right there. Remember, what is a graph? Is it a drawing of what is happening, or is it a representation of data? It is a representation of data. You do not draw on a graph what the thing that you're drawing looks like. Okay? Everybody cool? All right. Distance time for a graph for a runner completing a 400 meter race. Where would distance be? On the y-axis. What would it be measured in? Distance would be measured in time? Meters. What goes down here? Time. What would we probably measure that in? Minutes or seconds. Everybody cool? Now, it's a distance time graph. So, should the graph continually go up, or should it go up and down? Continually up. Why? Nathan? Not quite. Sam? It's just showing total distance traveled. Distance is a scalar. It's got no direction, right? So, at 0 time, how much distance has my runner traveled? 0. Excellent. At the end of the time, how far up the graph will I be? This will be 400. Now, let's talk about how the race could have happened. How do races usually start? What are you trying to do at the very beginning? Get a good start, right? You want to be in a good position. So, is that a steep line or a shallow line? Steep line to get a start, yes? And then once you're in a good position, what do? You settle down into a constant pace, yes? So would that be a shallower line or a steeper line? Shallower line. And then what happens right at the very end? Malik. It's going to be very steep at the end for your finishing kick, yes? That's the way it should look if you were running the race. Now, some of you maybe can't run 400 meters. Got to take a walking break in the middle. So what's going to happen to this part of the line? It's going to get really shallow, right? What if you twist your ankle and fall down? Then it's going to go flat for a while. Will it ever stop? Why not? Time doesn't stop. Displacement time, what's the difference? No. This time you're tracking where they are, right? So do we still start out with fast? I bet we do. And do we still start out, then do we settle into a nice pace? I bet we do. Then what happens when we get to 200 meters? What happens here? It changes because I start heading back to home, yes? Same slope, probably, because we're going to keep the same pace until when? The end, when what happens? Very steep for my finishing kick, right? If you did something like this, I'm perfectly happy, because it can get really technical, yeah? Just for a second, let's talk about what this would be technically speaking. What shape is a track? It's an oval, isn't it? Right? So there's straight part, but it's not even really an oval, because it's straight with a curve, right? No, an oval is curved all the way around. So this is more like a rectangle with two circles, yeah? And where do you usually start a race? Right in the middle here, yeah? So for a while you're running straight. Then you go under the circle, yeah? I'm still going away, but once I get halfway through the circle, aren't I coming back a little? And then I end up over here, and I'm really not very far away, am I? So the graph would look really, really weird if we were going to get really technical about it. But we're not, because I only care that you recognize that halfway there, you turn around and go home, essentially. Everybody cool? The concept is on a displacement graph, you go back home. Everybody understand? If you take physics 11 and you were doing something on like an oval track, then maybe the graph would be a little weird, because you'd have to measure all of these distances to certain data points and then connect the line. Everybody understand? Because in displacement, technically this, even though this is the 200 meters worth of running, I'm really only about 70 meters from where I started, aren't I? Everybody understand what I'm saying? So it gets really yucky if we were going to be really technical. But in grade 10, we don't need to be technical, do we? All we care about is the concepts. And what's the concept here? Distance goes all the way up because it's scalar. Displacement goes up and back because it's vector, because it's got a direction. Everybody understand? Okay. And now lastly, position time graph for you as you travel to school. Well, I can't do this for any of you because I know where none of you live. But for me, I'd have distance over here, and I'd have time here. Now, it's only to school, yes? So since it's only to school, even though it's position time graph, will it ever go home? No. So I got to drive from my house. It's 3 kilometers to the highway, right? from my house in Chilliwack. So what is that line going to look like at the beginning? Steep or shallow? Shallow. Why? Because I'm not on the highway. I'm on the roads, right? And technically, there's going to be a few flat lines. Why? Stop signs, kids crossing the street, whatever, right? So for the first little bit, how long do you think it takes for me to get to the highway? 5 minutes about. So, okay. So let's go out in fives. And remember, this is me. You can compare this to yourself. 25, 30, 35. So I leave and I drive a little, then I have a stop sign, then I drive a little more, and then I have a stop sign, and then I drive a little more. And here I am 5 minutes in, I'm 3K away. So we'll go up by 3s, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Everybody cool? Now, what's going to happen here when I hit the highway? So how do I show that on a graph? Steep. Why? Perfect. I'm covering more distance in less time, right? So when I hit the highway, I come onto the highway at exit 116. I get off the highway at exit 90. That means I have traveled 26 kilometers. A lot of people don't know that the exit numbers are kilometers. So I traveled 26 kilometers on the highway at 120 kilometers an hour. So that means it's going to take me 13 minutes on the highway, yes? On the highway, generally, do you think it's stop and go or constant? Constant. So I need 13 minutes, which will take me up to 18, yes? And I need to go 26K from 3 up to 21, 24, 27, 20, 30, 29 at 18 minutes. And that is going to be a pretty straight line, yes? What happens at exit 90? Why? I'm leaving the highway. I leave the highway right over there by the new Cabela's. Yeah? So I got to go through 1, 2, 3 lights before I get to here. And this light's a left turn. Right? So what's going to happen now for the last little bit? Stop and go. Right? So back to here. Go a little, stop, go a little, stop, go a little, stop, until I get up to the 32 kilometers. Now, if this was for my whole day, what would happen right here? Stop and think. What do I do for 5 hours right now? I don't go anywhere, do I? Flat. Till when? End of the day. Then what do? Would it be exactly the same? It would, if it was distance, it would keep going up. But since it's position, I would start going towards home, right? Now, could I just mirror the graph? No, because things are slightly different, right? In the afternoon, there's often some traffic going home, even on the highway. Everybody cool? You good? I eavesdropped on Olivia. She sounded like she handled it well. You're good? Okay.
How the swing set doesn't go backwards. It's like when you make a turn. It doesn't count for you going more towards home or whatever. So you turn the opposite way to get closer. If you always go straight there, like that doesn't count for you go the opposite way.
On a displacement graph, it does. This is what I'm about to tell you. What would happen if I remembered right here on the highway that I forgot my wallet? I'd have to turn back, right? I can't turn around on the highway, can I, Sage? I got to exit the highway, so there'd be one of these, right? Get turned around, get back on the highway steep, then here, home, then up, then to work. Everybody understand? What is the one thing I cannot do? Where can my line never go? Left. It can't ever go left. Why? Time can't go backwards. No matter what. Everybody understand? If distance isn't changing, is time still changing? Yes. Always. Everybody got it? Okay. Now, some of you I know did some work from 155 to 150, whenever the work ends. Is there any questions that people want to ask about? Right. Actually, you know what? This is important enough to me. I'm going to give 15 minutes right now. Nobody did all of these pages. Do some work right now. 15 minutes. Okay? Do some stuff on them. You decide, I'm a little bit dodgy on domain and range. Find some questions about domain and range. I'm a little bit crappy at reading graphs. Read a couple of graphs. I'm a little bit crappy at drawing graphs, because we just did 4 graphs, right? If your graphs weren't very good, find a couple that ask you to draw a graph. Does everybody understand? You use this time. What could this one possibly be? A sprint? If it were a sprint, I go really, 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 really fast. I get to there and then I start to slow down. Nothing wrong with that. What else could it be? Hiking up a mountain? As time goes on, my height goes up. I get to the top of the mountain, then I come down. Good. What else? Driving somewhere and coming home. Throw a ball in the air. Right? Run up. Yeah. As long as we recognize that we are speeding up and slowing down. Or going somewhere and coming back. Right? That's the key here. What could be happening in B? Something happens, and then all of a sudden something else happens, and all of a sudden something else happens. What could that be? This is a tricky one. What? Pardon me? A relay race with time stopping? What could this one be? Oh, look at you. So if this was a solid dot and a closed dot, it could be a relay race, couldn't it? Oh, sneaky. I like that. What else? Can anybody think of something else it might be? This question is tougher for you guys because it's not something that happens as often anymore. This, for me, what this represents to me is like renting a video game. You guys don't have video stores anymore. You pay for a day. What happens if you don't return it? You pay another day. What happens if you don't return it? You pay another day. right? Or another thing that you guys wouldn't be used to, this is how cell phones used to work. If you use them up to a certain amount, you paid that much money. If you went over that amount, you paid that much money. If you went over that amount, you paid that much money. You guys only have that with data now. Yeah, nobody uses their phone to call people except old people. You don't call anyone. You send a text. You send a text from the basement to your mom upstairs. Say, Mom, can you bring me some cookies? Yes, you do, and I know you do, because you're not going, no, I don't. Okay. How many of you have ever sent a text to your parents in the same house? Put your hands up, every single one of you. What could be happening in C? Nathan. Yeah, bungee jumping is a really good one, right? Because you speed up, and then at the bottom of your bungee jump, you're technically not moving, right? But then, wouldn't you speed up again? So you can't do it with weight, you can't do it with speed. Can you do it with distance? Displacement, because you're going away, 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 and then at the bottom of the jump, you'd go where? You get pulled back up. Now, the only problem with this not being bungee jumping is notice I come all the way back up to the top every time. So you have the right concept, but it couldn't work for here because I go all the way back up to the top. Fishing? Oh, I see. Okay, yeah. If you're jigging for fish, all right, what do you got? Skipping rope, yeah, that'd be a good one. You jump up, and then you come back down. Then you jump up, and then you come back down. Now, the only problem with that, Malik, is apparently you're floating in the air because you don't come back down to zero grounds, right? But that's okay. That's okay. Concept is what I care about. Nathan. Ooh, that's a good one. Amount of people in a restaurant goes up and down. Sure. Sure, yeah, swimming underwater. You go down to a depth, then you got to come back up for air, then down to a depth, then back up for air. Nice one. What about on a trampoline? Right? Up in the air, back to the trampoline, up in the air, back to the trampoline. Thanks, David. You're the best. And lastly, these are tricky. What's the difference? This one has a slant, yeah? So if I fill this one for this part, what's it going to look like as time goes on? Is it going to be a steep line, a shallow line, a straight line, or a curved line? It's going to be a straight line. Why? Because as I dump water in here, it's going to fill up evenly, isn't it? So it's going to be a straight line. Now, what's going to happen when I get to here? Is it going to get steeper or shallower? Shallower. Why? Because there's more to fill. Time will go on, but the depth won't rise as quickly, right? So I got to give a shallower line. Everybody understand? Okay, what's going to happen in the bottom one? When it's right here, how fast is the depth going to go up? Steep, because there's not very much to fill, yeah? But then it starts getting bigger and bigger and bigger. So what kind of line would it be? Curvy. It's got to start. Now, curvy this way or curvy this way? Bottom or top? Bottom? Top. Because it's going to fill up depth really quickly and then slow down. Then what happens when he gets here where it's a square? It's going to be straight line or curvy line? Straight line, and is it going to be steeper or shallower? Shallower than here because I'm filling up bigger. Everybody understand? Everybody good? Spectacular. Now, it is 9:03. Let's go over the test and see where we are time-wise then. Okay? David. I will... Actually, everyone, give me one moment while I mark David's, and then we'll go over the test. Okay. Polynomials test. Oh, David. Isabel. Way over there. Two sharps right here. Nathan's way over there. Cole's way over there. Yen is way over there. So I might as well start making this track. Cole. Yen. A wee. Gurja. Riley, Jenna, Jacqueline, way over there. Olivia, right here. Actually, right here. Oh, that was my fault. That was lame. Tajri, way over here. Oh, and there's Jordan. Jordan. Joe. Beer, Joe Tito's way over there. Devin's way over there. Let's see. Jade is here. Ethan is not here. Oh, if only he would find Goodwill Hunting. It would be so much better. Mr. Sahoto. Mr. Gurr. Way over there. Hell yeah. Mr. Gurr and Mr. Moto. First page is BDDC. If you need any of them explained, ask now.